So in this video, we're going to talk about how to write quadratic and square root equations using technology with Desmos. So remember that given a table of values, you can use quadratic regressions on your calculator or Desmos to write the equation of a quadratic function. So to do quadratic regressions on Desmos, remember you're going to open Desmos and then click the plus sign in the upper left-hand corner and choose Table. Then you're going to enter the values into the table, and then you're going to tell Desmos to approximate a quadratic function by entering y1 is approximately ax1 squared plus bx1 plus c. And then that's how you're going to tell it to figure out a quadratic function. Then it's going to give you values and parameters that you're going to be able to use to write the equation of a quadratic function. So let's start off with this example. Let's find the quadratic function that best fits this table of data. So we're going to start off by going to Desmos, clicking this plus sign in the upper left-hand corner, and then choosing Table. So now what we're going to do is we're going to enter these values into our table. So we have -1, 0, 3, and then the y values 13, 5, and 5. So now what we're going to do is we're going to type in our general form of a quadratic. So y1 is approximately ax1 squared plus bx1 plus c. So when we do that, it now gives us these values that we can use to write the quadratic function. Notice under parameters, it says a is 2, b is -6, and c is 5. So that's how we get our equation, which is y equals 2x squared minus 6x plus 5. Remember, that's based on the fact that general form of a quadratic function is y equals ax squared plus bx plus c. So all we do is substitute in those values of a, b, and c to write our quadratic function. So now you can go ahead and pause the video and try this quadratic on your own. So remember, you're going to go to Table and enter in your values. And then you do y1 is approximately ax1 squared plus bx1 plus c. So that gives us the values of a, b, and c, so we can now write our quadratic, which is y equals 4x squared plus 11x plus 2. So now we need to write the equation of a square root function. Well, Desmos does do square root regressions, however, they're not very accurate. So the better way to find the equation of a square root function is you're going to first find the equation of its inverse, which is a quadratic, and then once you find the quadratic, you're going to find the inverse of this function to figure out the square root function. So let me show you what this means. So you're going to create a new table, switching the values of x and y, and then we're going to go through all of our quadratic regression steps. So then we're going to use the values and parameters to write the quadratic equation, and then we're going to swap x and y back to find the inverse, which is the square root equation. So let's look at an example. Let's find the square root function that best fits this given table of data. Well, we want to find the square root function, but like I told you, it's not going to do the regression very well in Desmos. So we're going to find the quadratic that is the inverse. So what we're going to do is we're going to take this table and we're going to switch the x and y values. So I'm going to copy all these y values into my x column. So I have 4, 5, and 6. And I'm going to copy all the x values into my y column. So I have 3, 4, and 7. So when I do that, I'm going to go to my table. So now that's going to be a quadratic function, right? Because that is the inverse. So I have 4, 5, and 6, and then I have 3, 4, and 7. So I write the quadratic regression. y1 is approximately ax1 squared plus bx1 plus c. So it gives me the quadratic function. So I have the quadratic y equals 1x squared minus 8x plus 19. Okay, I can also write that as y equals x squared minus 8x plus 19, right? Because we usually don't write those coefficients of 1. Well, this is a quadratic. I want to find the square root. So now I'm going to take this quadratic function, this y equals x squared minus 8x plus 19, and I'm going to switch x and y, right? Remember, because that is how I find the inverse. So I'm going to write this as x equals y squared minus 8y plus 19. So what I need to do now is I need to get this into y equals form, okay? Remember, I need to solve this equation for y. Well, what I'm going to do now is I'm going to use that little technique called completing the square, okay? So I'm going to take this y squared minus 8y and I'm going to turn that into a perfect square trinomial. So what I'm going to do is I'm going to say y equals y squared minus 8y, and then remember I need to add something here, right? I need to add something and then I still have that plus 19, but then whatever I add, I'm going to subtract that also, right? Because I have to balance out my equation. So I'm going to add something here, and remember that something that you add when you complete the square is b over 2 squared, right? Remember that b is the coefficient of the x term. So you're going to take that number, so that's negative 8 divided by 2, and then you're going to square it. So negative 8 divided by 2 is negative 4, and negative 4 squared is 16. So I'm going to add 16 here. Well, I can't just randomly add things into my equation, right? So remember, if I add 16 here, I have to subtract 16 to balance it out. So that's how I complete the square. So now what happens is this y squared minus 8y plus 16, I can write it as a perfect square factor, right? So remember, the factor is it's going to be y, and then it's going to be b divided by 2, right? So y minus b divided by 2. So it's going to be that b divided by 2, so that's 4. So I have y minus 4 squared. And you can actually write that out and check it. You can verify that y minus 4 squared does equal y squared minus 8y plus 16. Okay, so now we've taken care of these three terms, but we still have this 19 minus 16. So that's going to be plus 3. Okay, so remember the whole goal of this, we want to get y by itself. Okay, so y is still not by itself, so we need to rearrange some things. So I'm going to start off by subtracting 3 from both sides. And when I do that, I get x minus 3 equals y minus 4 squared. So now I have to, I'm going to do some erasing to get some room over here. So now I need to still work on getting y by itself, but I'm getting a little bit closer. So I have x minus 3 equals y minus 4 squared. So now the next big thing I need to get rid of is I need to undo this squared, right? I'm going to take the square root of both sides to undo the square. So I have the square root of x minus 3 equals y minus 4. So now I'm finally close to getting y by itself. So what I'm going to do is I'm going to add 4 to both sides. And when I do that, remember that 4 has to stay outside the radical because it doesn't go under. Whatever's under the radical is going to stay there, and then the plus 4 is going to be on the outside. So that is y. So now I finally have the equation of my square root function, which is y equals the square root of x minus 3 plus 4. And that is now my final answer. So now you can go ahead and pause the video and try this problem on your own. So we're going to write the square root function that best fits this table of data. So remember, once again, we're going to start off by switching our x and y values. So all my y values are going to become my x values. And then all my x values are going to become my y values. So I'm going to enter this new table now into Desmos. So I click Table, and then I enter my values. And then in y, I'm going to enter these new values. And then I'm going to write my quadratic. y1 is approximately ax1 squared plus bx1 plus c. Okay, so now I have my quadratic, which is y equals 1x squared plus 10x plus 23. So that is y equals x squared plus 10x plus 23. So now this is my quadratic, but I'm not interested in finding the quadratic, right? I need the square root function. So I'm going to take this y equals x squared plus 10x plus 23, and I'm going to switch my x and my y. So when I do that, I get x equals y squared plus 10y plus 23. So once again, I'm going to use the technique I did on the last problem to complete the square and get y by itself. So remember, once again, I have x equals y squared plus 10y, and then I'm going to add something here, but then to balance it out, I'm going to subtract whatever I added. So I have y squared plus 10y, so remember that means that b is 10. So I'm going to take that b divided by 2 and I'm going to square it. So I have 10 divided by 2 and I square that. So 10 divided by 2 is 5, and so 5 squared is 25. So I'm going to add 25 here, which means that I'm going to subtract 25 over here to balance everything out. So now I can write this as x equals y plus, and then b divided by 2, so that's y divided by y plus 5 squared. Then I have 23 minus 25, which gives me minus 2. So now I can work on getting y by itself. So I'm going to start off by adding 2 to both sides. And so I get x plus 2 equals y plus 5 squared. I need to take the square root of both sides. So I have x plus 2 under the square root equals y plus 5. So when I have this now, this x plus 2 equals y plus 5, I'm going to subtract 5 from both sides, and that gives me the square root of x plus 2, and then minus 5 is going to stay on the outside, that equals y. And that is the equation of the square root function that I was looking for. So in summary, remember that using a table of values, you can write the equation of a quadratic using quadratic regressions on your calculator. You can write the equation of a square root function by using your calculator to find the inverse, which is a quadratic, and then you can find the inverse of this function to find the square root function.